Tom, do you want to kick us off? I think it seems like a good time to get started.
I certainly can. Allow me then to just get us started here. My name is Tom Bradley. I serve as Woodward Professor and Department Head for the Department of Systems Engineering here at Colorado State University. And we're here to welcome you to this on-campus Master's and Ph.D. program info session. And the big idea here is basically to give you a little bit of information about our department, about what the process of admission looks like, et cetera, et cetera. So here's our just general agenda. And, we're going to talk about, I'm going to give you some introductions to some of the key folks who are on the call and are part of our systems engineering department. I'll give you a little bit of introduction into systems engineering. This is one of the most common questions we sort of get asked, but we'll talk about what systems engineering really is. We'll talk about our department and these kind of things. Let's discuss research and funding opportunities that exist within the department. I'll have Ingrid tell you a little bit about some of the application information and what some of the grad student resources are, and then we'll have myself, staff, faculty around to be able to answer some Q&A. So I think the big picture there is if you enter Q&A into the chat and these kind of things, we'll be able to see it and we can address it as we go along, and or we can also sort of save it up for the end if there are any big questions too. Okay, so with that, I'll just do some very quick introductions. So I got to introduce myself. That's me on the left side there, department head, and I'm a professor in the College of Engineering here. Also want to introduce Ingrid Bridge. She's our program coordinator and student advisor for the Department of Systems Engineering, and Catherine Peterman, who is our communication and marketing coordinator. So we're the folks who will do the primary sort of presenting of the materials here. We also are joined on this Zoom call by a couple of our faculty members who will also be making introductions and telling you a little bit about their research programs and such. So with that, just to kick us off, then let me give you a quick introduction into our Department of Systems Engineering and what systems engineering is really about. So, many of the students who are applying to graduate school in systems engineering sort of, come from disciplinary backgrounds. And what I mean by that is, you're trained excellent mechanical engineers or electrical engineers or civil engineers or mathematicians or computer scientists or whatever, right? And that's great. Those are important parts of course, being an expert engineer. Well, what happens, you could ask the question, right? You might do your electrical engineering activities and you work in a big program that's trying to build a satellite or something like that, right? And you do electrical engineering activities. But the question becomes sort of like, okay, well, how does that fit into the bigger whole? And what's the engineer? What's the person? Who is the person who is doing those integration tasks? Like, who is responsible for the whole satellite? And who's responsible for that satellite and its presence within a communication system or within a defense system or all these kind of things? So inevitably, as we sort of develop as engineers, we get very, very good within our discipline. But there's also a role to be able to think about systems and the role of electrical engineers within a particular system. So what systems engineering is, it's a field of study of engineering that really, instead of concentrating on depth, as you might have done, within an electrical engineering or mechanical engineering curriculum, systems engineering really concentrates on the design and the application of the whole system as opposed to just its parts. Systems engineering, because we're concentrating on that entirety of the system, that means that we also need to think hard, not just about technical processes and not just about technical expertise, but also about teams and management and these kinds of activities. It means that we need to be able to cross disciplines. We need to be not just expert in a particular aspect of engineering or in a particular subsystem where we place all of our emphasis. We need to be able to sort of cross disciplines and be able to think about big problem sets and making contributions across subsystems. So the exciting part, of course, about thinking about systems engineering as a discipline is it means that we have a unique responsibility for the function and for the design, for the architecting, for the management of big problems and big systems. So it means that systems engineering is really a domain where you can make an impact on problems like sustainability, or on a problem like space travel, or on a problem like, how to think about smart grid, or these kind of things. Those are not disciplinary problems, but they are systems engineering problems. So that's the idea of systems engineering, is we sort of give you as a toolkit, a capability, a way of thinking that allows students to be able to really address what I think are the most important and biggest problems that we face as a society. So, a little bit of a philosophical diversion there at the beginning of our discussion. But with that, then I would want to give you a little bit of background into what some of our department looks like. And for that, I will hand over to Ingrid Bridge, who is our department graduate advisor.
Thank you, Tom. So yes, I'm definitely excited to walk through some of our program options. We have 2 master's degrees and a PhD available in our department. And I'm going to spend a little bit of time talking about the master's. We have more variety in the master's, so I'm going to spend a little more time on that. Bear with me if you're interested in the PhD. So we have the Master of Engineering and the Master of Science programs. And one of the most frequently asked questions for me is, what is the difference between these 2 programs? So the Master of Engineering is a common degree in industry. It is usually for folks who have a few years of work experience, would like to come to graduate school to gain a new skill set in systems engineering, and then they want to go back into industry. So we often see students, find that this program is kind of a quick, easier program, because it's also not, we don't require a project or anything, so it can be completed coursework only. Essentially, you can take 10 classes with us, learn whatever you kind of want to learn about, and then graduate without any other type of project required. We also have a curriculum difference. So the Master of Engineering has kind of the intention to create a more broad skill set for our students. We have some required core classes to set a foundation for you. And then you have some systems depth courses that you can pick and choose, however you'd like to customize your program. And then you have a few electives. So that's kind of what our Master of Engineering would look like. The Master of Science is a little bit more common in academia. And certainly if you were interested in going on for a PhD at some point, I'd recommend the Master of Science for you, because it has the potential to do a little bit more individualized research or projects. It does require either a 3-credit project or a 9-credit thesis. And I'm going to talk about that in a little more depth in just a moment. And the Master of Science has a little bit more flexible coursework. So about half of your degree you would choose from a variety of systems options. You can kind of pick and choose, again, whatever you want to focus in. And then the other half of the degree is electives and your credits towards your project or your thesis. So it's a little bit more just flexible for how you want to tailor your degree program. So next, so yes, the Master of Science has the thesis or the project option here. I'm going to quickly run through this, because if you are applying for the Master of Science, you will see in your application Plan A or Plan B, and you might wonder what that means. So the thesis track, as I mentioned, 9-credit research project required, and this usually spans multiple semesters that you're working with a faculty member on your research. The number of pages, this is just to give you an idea of scope. It varies widely depending on what kind of research you're doing here. The thesis track does require a faculty advisor to be secured prior to admission, since you will be working so closely with them on your thesis. And it does provide an opportunity for an intensive research experience. This is particularly valuable if you think you might want to go on for a PhD. The thesis is a great way to gauge that and get some really good research experience. This degree also does require a thesis defense, where you get up in front of your advisory committee and your friends and family and whomever you invite, and you tell them all about all the research that you've done in the last, during your master's program. So the Plan B then, project, is a smaller, usually 1 semester, 3-credit project. And this is viewed as kind of a capstone. So you go through your program, you learn a bunch of interesting things, and then you choose some project that's relevant to your professional goals, or maybe your employer. And this is a much smaller scope project. Again, the pages can vary. Sometimes you end up with an academic or a professional publication from this. But again, this does allow you to work one-on-one with a faculty member on some project of interest to you. And then the PhD program we do have, and this is very research centric. So this is going to prepare you you're going to learn how to do rigorous and excellent research in the systems engineering field, going through the peer review process, disseminating your research. Because this is so research centric, we kind of organize our program a little bit more flexibly. And so again, you're going to take some courses, but we have a lot of options of courses and none of them are explicitly required. So you can pick and choose the courses that are going to inform the research project you will be working on. We also have a little bit more flexible structure in that, if you are thinking, oh, when should I start research? We have some students who start in their very first semester. We have some students that wait until they're done with their coursework. It's really between you and your faculty advisor when you can start those research credits. We also, don't have a qualifying exam. We have a qualifying process instead, which has to do with grades earned in your coursework that you do take. Preliminary exam is required, but there's no, hard deadline as to when you have to complete that, after a certain number of semesters in the program. So again, very, very flexible and very tailored toward making sure you are having a successful research experience. We do have a recent distinction of being the largest doctoral program at CSU. And of course, we have online students in addition to our on-campus students. So this includes all of our students. But what this means for you as a prospective student is that we have students in our program that are doing research not just in labs at CSU with our faculty. They're doing research, across the country and across the world in a variety of different industries. And these are going to be your classmates. These are going to be the students that you can come and listen to like a research talk and learn from and collaborate with. So that's the program and that's the community that we're really building at CSU in the PhD program. One last mention you might notice as you're looking through our materials, the Doctor of Engineering program, or the DEng. And we're not talking about that today because that's really more focused for industry professionals, usually online students, and those who are usually funded by their employer. So if you have questions about that, feel free to ask out, but we're not going to cover that today.
Great, thank you, Ingrid. So at this juncture, I will do some discussion about the opportunities for research and funding of your time at Colorado State University. So next slide, if you don't mind, Chris. Thank you so much. And yeah, the big idea here is that if you are interested in any of these topics that we've been talking about, and you're interested in the Master of Science or the Master of or the PhD program, then we have graduate research assistantships that are available to be able to support students to go through our program. And this is basically a full ride scholarship to be able to come to graduate school. We pay for tuition, we pay for a stipend that, it's sort of a salary that allows the students to, to live comfortably in Fort Collins, do all this kind of stuff. This is applicable both to domestic and to international students. So what we'll talk about next is where there is some opportunities for you all to be involved in systems engineering research. I'll do some very quick introductions here, and then we'll sort of pass the baton back and forth. So I got to introduce myself already, Tom Bradley. Dr. Erika Miller is an assistant professor in systems engineering, and she's going to talk a little bit about her research. Next is Dr. Dan Herber. Dan's an assistant professor in our department, and it's going to talk about his research opportunities. And then last but not least, Dr. Stephen Conrad. Dr. Conrad is an associate professor in systems engineering, and he's going to talk a little bit about some research opportunities that come up in his lab group. So the big idea here is, if you were to, if you find interests here, or if you sort of see topics that that would excite you, or where you'd like to be able to invest a little bit and be able to spend some time doing systems engineering research with these faculty, then feel free to make contact. You see emails across the bottom here, etc. We are actively looking for students who we would be able to support to come to graduate school. So to kick us off then, perhaps I'll talk a little bit about some research opportunities that I have. So right now, and this is sort of planning for the next academic year that would start in fall 2022 or summer 2022, we have a couple of opportunities. We have a local company that's an aerospace company. It's called Woodward and Woodward Inc. And they have funded projects at Colorado State University around, number one, aero actuation, which is basically the control surfaces around these aircraft, some controls and integration and modeling problems on that front. The second project there is about fuel cells. So if you're interested in sustainable energy and fuel cell systems and that sort of stuff, we're going to build up a fuel cell test bed on campus. The third one is a fuel cell project that we have with Lockheed Martin. It's funded by Lockheed Martin. And the idea is we're actually going to build a fuel cell power plant for this UAV that you see on the screen right here. So we're going to try to build up the capability to design aerospace sort of grade fuel cells. And then the last one is that I have a project that's with the Electric Power Research Institute that works on modeling of electric trucks and these sorts of things. So again, you know, if any of those topics sound interesting, give me an email. Let's talk about it. Let's see if we can make a connection. I'm going to seek to support about 4 students to go through our program next year. Might be of interest to you. With that, then I'll pass the torch. I believe the next person in line is Erika Miller. So Erika, go right ahead.
Thank you. So yeah, I'm going to talk briefly about some opportunities in my lab, which is the Human Systems Lab. And I just selected 3 projects here. I think I have a few more coming up. These are kind of the ones that are more near term. But basically my lab group looks at transportation and human factors. So I'm looking for probably 1 PhD and or 2 master's students to do some work with human factors, data analytics, and it would be icing on the cake if your your passion is transportation, but that it doesn't have to be necessarily coming in, because I think I can persuade you to get excited about some transportation related research. So the 3 projects that I'm kind of, again, just highlighting here, because those are the more near-term needs that I have. The first is basically looking at mitigation methods and signage currently used for reducing railway trespassing events. So just brief background on that. One of the leading causes of deaths relating to railroads is that people just, cross the railroad tracks when they're not supposed to. And so I have a funding opportunity to look at, what current mitigation methods are in place to prevent these railroad trespassing events. And then a follow-on to that is to develop a survey study to capture some public perceptions relating to, what's safe and some interpretations of current signage usage. So if you are interested in doing some survey analysis, that would be a project of interest. The second one is another potential project that I have coming up with the Colorado Department of Transportation. And that one is looking at, how vehicle automation can help with some of their maintenance tasks. So, again, brief background, many DOT tasks that are currently, in the works that they do could benefit highly from, vehicle automation, automation on the vehicle, but also infrastructure. And so this one is, strictly a literature review project. So, reviewing the literature and publications out there to just understand, where automation can be implemented better. And also, sorry about that. And also, tasks that could be utilized. And then my last one is, that's, COVID life, I guess, right? Really quickly, the last one is there is an electric or autonomous shuttle operating in Denver, and there's interest on expanding that service. And so that would also be a survey study to just understand, public perceptions of, getting in a shuttle that is fully autonomous without a driver on board, and, how might that be expanded to improve trust with that shuttle. So those are my my prospective projects.
Yeah, this is one of my three as well. I have a quick slide on each of them. Again, I'm Dan Herber, assistant professor in the department. This first one is, there's a number of topic areas related to this. It's advancing model-based systems engineering. So looking at this kind of figure on the right, one of the ways that we can help manage complexity right in a systems kind of perspective is to model the system in perhaps a very rigorous way. We use techniques kind of called model-based system engineering. A simple example I have here is for a UAV, where we can model its structure, like what parts are there, but also the behavior, right? The actions of taking it off and landing, but right, different pieces of the system have different actions, and we can model those and the sequence of them and how they're related. Another major area is requirements. What should the system do, and how can we ensure that the system design meets those requirements? And finally, parametrics, right? We might want to compute things like efficiencies, or right, is the temperature met? So a system level model in model-based system engineering is trying to build this cohesive vision, right? These are interconnected diagrams, interconnected model for the system. So we have a number of projects in this area. Essentially, some of these overlap with what Tom was maybe mentioning in a lot of aerospace applications and defense applications. All of these projects are appropriate for master's level students. So I'm looking for both master's and PhD level students for this particular project, if you're interested in kind of learning how to do this modeling, but also, we want to advance the research here. So there's a number of interesting questions, but this is a topic that, right, if you come here for this one, this is one where you could find a job probably quite easily. A lot of companies are looking for students in this space in particular. Next slide, please. Great. So the next two are somewhat related. They're both funded by by ARPA-E, which is a government organization that funds kind of cutting edge energy research. So a lot of work that my group does is in the energy space. Both of these are in the renewable space. This first one is for hydrokinetic energy systems, and it's focused on building design and optimization tools. Like, we want to know how to make these things work and how to make them efficient and cost effective. And we're putting them underwater. So we're putting things like, we look there, we have kind of a horizontal version of this where the current can come and push it and rotate it, just like the wind pushes a wind turbine. Sometimes we frame this as putting the wind turbines underwater so that there's a new fluid pushing it. But there's a number of interesting challenges here. A lot of my work here is primarily computational. We're building physics-based models, then optimizing those models in terms of getting the best performance. This is in collaboration with the National Renewable Energy Laboratory. And again, this is another project where master's or PhD student would be appropriate for it. Next slide, please. And now this one is primarily funded by NSF, the National Science Foundation. It's in the energy space as well. It is for wave energy farms. So right, instead of the last one, we're putting things underwater and trying to get energy. Now we're putting them like on top of the water, and the motion of the ocean waves, we can extract energy from that as well. So this one is looking at, is in collaboration with civil engineering here at CSU, but we're doing a similar activity, optimizing the size of them, what we call the control, right? Should we be like, how do we actually move these things so that it actually extracts energy efficiently and they don't break or things like that. And this is looking at specifically the challenge of arrays of them, right? We can't just put one in the water and hope it gets as energy. We need to put lots of these, and they interact, right? Things in the water cause waves themselves. So understanding those interactions, those are some of the factors here. This project, I'm really looking for someone who wants to continue on to their PhD just based on some of the research tasks associated with this, but someone who's, starting out, right, coming from undergrad to grad school, but wants to continue their PhD would be a prime candidate for this type of work. But yeah, with that, on the bottom of all those slides, I have my research group website and my email address. If you are interested, please reach out and I'd be happy to have a continued discussion. Thanks.
Great. So I'm Dr. Conrad, and I'm starting up a new lab here at Colorado State University called the Coupled Systems Modeling Lab. And essentially what we're going to be looking at in this lab is the integration of social sciences and sort of engineering principles to investigate and model kind of the dynamics of systems. And a lot of the work that I work on is that human sort of water, energy, food system integration side. So we'll be looking at interactions between water and energy systems, interaction between food and water, those types of things. And the main objective of the lab and the work that I do within this particular lab is to inform both system optimization of these large scale systems, but also decision making. So I'm looking for a number of new graduate students to work with me, both at the master's level and PhD level, depending on things. Some of the projects that are going on currently in the lab include, doing some work on investigating sort of the impact of different types of conservation signals. So imagine you receive, a notice in your mail that says how much energy you were using when you were, flushing your toilet as opposed to the amount of water, and vice versa, since there's an integration and connection between water and energy. We're doing a lot of work on sort of adaptive AI and artificial intelligence and machine learning within the lab, and tying these machine learning models for applications within the water, energy, food nexus, things like water treatment or system optimization. I'm looking at building digital twins of water and energy systems. Within the lab, we'll be doing a lot of work on decision visualization. So what are the ways that we can present information to decision makers, and how do they visualize that information? Work with that. So starting up a new cognition lab focused on sort of the human machine interfaces, looking at the visual cognition of things like smart displays, computer displays. What do we look at? What gets our attention? What helps us to make decisions? What do we avoid? What do we ignore? Those types of things. A couple other projects real quick, having some work on routing agricultural waste to generate urban biogas through running that waste through wastewater treatment plants, and also have an ongoing collaboration with University of Queensland and Delft University, looking at how do we design water and energy efficient urban areas. So lots of research opportunities, lots of partners we work with, the Water Research Foundation, National Renewable Energy Laboratories, like Dan had mentioned. We have some work going on with the Metro of Vancouver in Canada, the City of Fort Collins, Electric Power Research Institute. So if any of these kind of things interest you, do reach out to me, and I'd love to open up a conversation with you. Thanks.
Great. Just to, so again, you sort of got a little bit of the impression. I gave you that warning again, that systems engineering is about breadth, right? So you see here, topics like sustainability and topics like the human interface and thinking about transportation systems and energy systems and all these kind of things. Where all of those things intersect, that's where systems engineers are doing their work. Maybe just next slide, Catherine, if you don't mind. So I'll just bring up a couple of these key points here, which is that, in addition to graduate research assistants, we do have opportunities for students to also get funding through other mechanisms. The first one that's bullet pointed there is graduate teaching assistantships. And of course, these are, your TAs for classes. We're really looking for outstanding students and capable students. We have about 6 of these positions to fill every year. And so there is a great opportunity to, for you to demonstrate your expertise in a class and then come back and TA it. So that's something that often students will do, in their perhaps like second or third semesters of school. The second bullet point there is I encourage every student to apply to the university-wide scholarship application. This is sort of a way that through a single, application source, you can have your, resume and your experiences go to a variety of scholarships that are available throughout the university. So some of these are merit-based, some of these are based on need, et cetera. And so there is some opportunity, again, for students to apply for that sort of stuff. And then the last bullet point I bring up is that we have a number of faculty in systems engineering who are engaged in this quite prestigious program that's called Interfuse, and it stands for intersections within food, energy, water systems. And so, of course, systems engineers have an important role to play. But if you're interested in cross-disciplinary research, especially for folks at PhD level, if you're interested in food, energy, water. If you're interested in collaborations with departments of the Department of Ag, or if with our civil engineering water folks or something like that, then you might consider go to the Interfuse website. You can easily Google it and seek out to apply to that program. And you can identify a number of our systems engineering faculty as key faculty in DIP. So at this point, then I'll hand it back over to Ingrid in the hope that she can talk a little bit about some of the application process and what this might look like.
Yes, so hopefully by now you're thinking, well, this all sounds lovely. How should I apply? And so I'm just going to walk through some of the basics of the application and then cover how you would get the application fee waiver, which we're offering to students applying to on-campus programs. So the first step is that we have on our website for all programs an application information checklist. And I would encourage all students to go to our future students page, download this checklist, and then carefully make sure you're following it. It covers the minimum requirements. Thank you, Catherine, for putting that link in. It covers the minimum requirements for each program, and then every step that you need to do, each requirement to meet to finish your application so it's as complete, as competitive as possible. The timing on our application process is that we do have rolling admissions, and what that means is if you submit a complete application to us, we can usually get you an application decision within about 1 or 2 weeks. So the earlier you apply in an application cycle, the earlier you can know if you were accepted. There is a final deadline noted for all of our programs, and do please make sure that you have not only submitted your application by that deadline, but also all of your application materials are received by the department. That is the final deadline. And that's when we start reviewing for our final section of the class. And so there's not a lot of flexibility after that deadline. My next tip here is, as you are looking at our application requirements, make sure not only that you meet the minimum requirements that we have listed, but also that you know where in your application it shows that you meet those requirements. So, for example, we have math prerequisites, Calculus 1 and basic statistics, and so maybe you haven't taken a statistics course formally, but you use it in your job. In that case, just reach out to me and make sure that we can strategize about how to reflect, that you meet these minimum requirements in your application. The application materials are all that we have to review your background and your qualifications. And so we want to make sure we're not overlooking something and that everything is reflected accurately in your materials. Of all of our master's programs and the PhD, we have some common elements that you would be required to submit. The first is a current resume or CV. And I do recommend, as with any position that you might be submitting a resume for, please tailor this resume for the systems engineering graduate program at CSU. So we're going to be looking to see highlights of, what about your background makes you qualified for this program. We also require a statement of purpose, and this is 2 pages for you to tell us, anything and everything that you would like to about why you're excited about, the systems engineering program, why you're excited about CSU, how you think we can help you with your professional goals. Any of these things you can cover in the statement of purpose. We do require 3 letters of recommendation at a minimum. You can submit more if you would like. Of those 3 letters, we tend to recommend that at least 1 is a faculty member from your previous education experience. If applicable, if you have any technical professional background, 1 is great to be a supervisor that can speak to your professional technical experience and skills. And then the 3rd person can be anybody else, maybe colleagues, maybe other supervisors, maybe additional faculty that can speak to your skill set that would make you successful in systems engineering or in graduate school in general. The GRE scores are now fully optional for all applicants. You could submit GRE scores if you'd like. Some students maybe have taken the GRE to apply to other programs and they're strong scores, so you could submit those. Or maybe if you feel there's a weaker area of your application, you might take the GRE and try to bolster your application. Those are valid reasons to submit. We will never compare GRE scores between applicants. We only consider them as kind of part of your holistic picture if you're qualified and ready to begin graduate school. For international students, if the primary official language of your country of origin is not English, you will be required to submit English proficiency scores. The only exception is if you have a recently earned degree from a United States institution, you may be eligible for a waiver of English proficiency scores. And then finally, we do have the graduate school application fee. I will cover in just a moment the process for the application fee waiver. The last point here is for the MS Plan A, so that's the thesis track, or the PhD application. Step one, and one of the most important steps of your application process, is to locate a faculty advisor. Now, the PhD, it's research centric. It's very important that from the beginning you're working with your faculty advisor. And step one on your application checklist highlights this. We have information in our application checklist, how to seek an advisor, kind of, what types of information can you provide folks. But you will have to have that faculty advisor agree to advise you before your application could be even reviewed. We cannot admit a student that does not have an advisor secured. With the MS Plan A, if you're planning to come in and start a thesis, you will need to locate a faculty advisor. If you submit your application, you don't have an advisor name, we would automatically consider you for the Plan B project track. So if you really want to do a thesis, but you can't find an advisor right away, you could be admitted to the Plan B, and then you could find an advisor maybe while you're here and swap to the Plan A. That's a strategy some students use. However, you cannot get into the program, the PhD program, without having that advisor before your application's reviewed. All right, so next up is the application fee waiver information. Perhaps this is why you are here tonight. And the steps to complete this here. So first, if you are applying for an on-campus master's program or an on-campus PhD program, and you meet all of the minimum requirements that's listed in our application packet, then you can be eligible for this waiver. The way this will work is when you go to submit your application, basically there's an online application. You're going to fill out some personal information, contact info, those things. You're going to upload a resume and your statement of purpose, and you're going to include all of the names and contact information for your letter writers. At that time, you can hit submit on your application. That will not just send us an incomplete application. What that does is gives you a checklist. It gives you access to a checklist that shows which of your recommenders have submitted their letters and which of your transcripts have been received. So you can keep track of all of these items and see when it's complete. Now, when it's complete and you have no more red X's, everything's been received, and the only thing you have left to do is pay, that's when you will email our department. Please have the code SYSE payment in the subject line and include your full name and the semester you're applying for. And then we will cover your app fee. It's a fairly simple process, but feel free to reach out to me or that department email listed there if you have any questions. All right, and just a quick plug here on if you were to come and attend CSU, what are some of the things that you might be interested in knowing as a graduate student? So the first list here is that we have a variety of resources for graduate students at CSU. In the department, outside of the department, the graduate school hosts a lot of very excellent workshops and trainings and things. So within our department, we have a few student committees, like student-run committees, very active. We have the Diversity, Equity, and Inclusion Subcommittee. We have the INCOSE RAMS chapter, and INCOSE is the International Council for Systems Engineering, which is kind of the primary professional organization in the systems engineering field. So we have a very strong presence, and our students are very active in that particular organization. And the American Society of Engineering Management is another prominent organization that systems engineers can join. We also have Friday talks in the department. These are opportunities for faculty and students to connect, for us to kind of talk about just things that can help student success, have students connect with each other, those types of things. On the campus resources side, this is just a small list of the variety. Like, there is so many things that CSU can offer to students. So essentially, no matter who you are, what kinds of things you like to do, there are going to be clubs and activities and student organizations that you can join and that can support you. And then we have one last why
Yeah,
I hear you.
I can speak to that just to maybe close
Okay.
this out again too. Thank you, Ingrid. So next slide, if you don't mind, Catherine. Great. The last thing to mention here is, I don't know where everybody's from or whatever, but of course, Colorado is an outstanding place to be able to spend some time to undergo your education and to be able to spend some fun time at grad school. We have lots of outdoor activities, and the mountains are very beautiful, and Fort Collins itself is actually a really wonderful town, very student oriented, a great place to be able to spend a couple of years. A couple of these bullet points are relevant for you here, but just know, of course, that Fort Collins is a really wonderful place to be able to have family, to be able to go out and go downtown, to be able to do mountain biking or skiing or whatever sorts of things you might be interested in. So that's really the only bullet point there. And then, of course, Colorado State University is really sort of the focal point and center of our town. We have about 165,000 people who are in the city of Fort Collins, about 30,000 of whom are associated with Colorado State University. So it's sort of a nice college town. There's lots of fun stuff going on football games Saturdays, and all these kind of things. So lots of opportunities to kind of get out and do fun stuff. So then, with that, I think we just sort of invite some questions, or if there's topics that you feel like we didn't cover, or if you want to try to, ask some questions to the staff or faculty, we're certainly open to those kind of things. So with that, then thank you a bunch, everybody, for participation, and we'll just open it up to Q&A. Yeah, so I'll maybe, let me read out loud Adriana's question, and I'll defer or I'll ask for Ingrid for some support on this too. So Adriana asked, how long are the Master of Engineering and the Master of Science programs? So these really depend on how many courses you're willing to take and what your sort of schedule is for graduation. So the total number of credits that are required for the master's programs, Ingrid will correct me if I'm wrong here, but I think are 30 credits, right? And so, you can think about each course as sort of 3 credits per regular course that you might be engaged in. So for most students, that takes about 2 years or so. There is the opportunity to go faster, especially in the Master of Engineering program, because it's not so oriented towards research activities. And so, for example, we have summer courses that are offered. And so if you have the opportunity to take summer courses, then that could be a way to sort of speed up your passage through the program. So at least maybe that's some orientation. Other comments there, Ingrid?
I would say too, in my experience, that a thesis master's student may take, 2 years is a very common time frame for most of our students, but students who are doing the thesis might take an extra semester or 2, depending on how, when they start their research, how thorough and what the scope of the project is. So that's the only thing I really see usually extend part-time enrollment, or a thesis might extend it past the 2 years.
Yeah, I'll say out of the dozens of students that I've had through Master of Science program, 90% of them do it in 2 years, and the other 10% do it in 2 years and a summer or something like that. I think it's quite typical to get through in that time frame. Yeah, so then Mohammed asks, okay, how about the PhD program? That's fair, right? Good. Yeah, so again, the real answer here is, of course, it depends on the student, it depends on the advisor, it depends on all these kind of things. We have had, it is possible, we've had students get through the programs, start to finish in on order of, 3 years and a semester or something like that. That's not unheard of. We have had students who take significantly longer. And it really just depends, again, on the scope, of your project and whether or not you could be sort of actively engaged in research in the first couple of semesters. It's very important. This is a topic that you should openly discuss, I would say, with your faculty advisor. What are your goals? What are you trying to accomplish in the PhD? What are you really interested in learning? If you're interested in an academic career or in a research and development career, it might sort of behoove you to make sure that you're getting lots of publications and lots of networking and lots of summer interns at the right institutes or these kind of things. And those can take a little time, but they're worth your while if it helps you to accomplish your goal. So the way I'd sort of say it, again, if you're looking for sort of default answers, I mean, expectations might be that students take about 4 years to get a PhD in engineering post-masters. But again, there's some flexibility around that depending on your particular goals. So.
Okay, thank you, Dr. Tom. Can I talk instead of writing if possible?
Of course, yes, please. Yes, please.
Okay, thank you, first of all. And I have 2 questions in here. I have a master's degree in biomedical engineering since 2005 and experience teaching in universities since that date till recent. And my question, I don't know if I'm late now to do the PhD or not. This is a different story, but I still have a passion to do it. And my first question talks about the IELTS or TOEFL requirements. So I'm not international student. So, but my origin not American, not UK, you know what I mean?
Yes.
But
yes.
I don't know if that allow me to be waived.
Yeah, so let me have Ingrid address that question because she certainly deals with the mechanics of that all the time.
Yeah, so I'm sorry if I missed this. You said you have a master's in biomedical engineering. Is that from a United States institution?
Actually, no, it was from Germany, but it was international program in English language. So my transcripts, my certificates, all originally of English language. My bachelor degree as well, English language. And my 16 years experience teaching in universities in English language. So, and I have a permanent resident in the United States. So I'm a domestic student, not international one.
Yeah. So that might be something we might have to, you have to send me some info and we have to check with the graduate admissions office. Unfortunately, the department does not set the English proficiency requirements, so I couldn't promise anything, but certainly we can chat about what your background is and check with them if that would qualify.
Good enough. And the other question is about the background. My background is, as I told you, biomedical engineering, and the bachelor was in 2002 in applied physics. And am I able, I mean, depends on your knowledge and experience with the student, previous students. Do you have all the students with the same curriculum of your majors in the PhD specifically? Like, I mean, are they studied like system engineering before or related subject?
Let me speak to that a little bit because it's I sort of alluded to it, but I can be more explicit perhaps, which is, we absolutely attract students from almost every discipline of science and technology and engineering and mathematics and computer sciences, et cetera. So we have folks from a variety of backgrounds who come into our systems engineering program. And, I mean, the essence, of course, of our systems program is that we train you to be a systems engineer. And that's the essence of it. And if you bring, our prerequisites and the sort of charge to be able to bring a technical background to the program, that's on purpose, right? Because we want you to be able to have the skill set in mathematics and in statistics and in technical know-how that will allow you to succeed. But on top of that, our objective is to be able to train systems engineers. So your background is not atypical. It is not the case that every one of our students has a systems engineering master's before they get into the systems engineering PhD. So I wouldn't, I would encourage your application with exactly the background you have. That sounds quite effective and interesting. Yeah.
I appreciate it. So that gives me a big relief because I'm interested to do that. I'm living next to you in Kansas State, so
Nice.
very
Yeah,
near.
great.
And the other thing is, I was thinking that, okay, you have the lab, okay, you have this new student, okay, go ahead, this is your lab and work alone. No, I don't believe that will work, right? No, you take.
No, every one of the lab groups, every one of the projects that you've heard, we have, we have dozens of students who we are supporting right now to work in our laboratory space on campus. So everything we're describing, I mean, I'll say it out loud again, systems engineering is a team sport. And so systems engineering research is a team sport. And so you'll find collaborators among the faculty, among the students, among folks from the departments across the street or whatever. That's the university model. So I just would be encouraging about that.
Excellent, excellent. Thank you so much. The rich information you gave me. Thank you so much.
Awesome. I think we'll start with Ethan's question in the chat. So this one might work for Ingrid. So he asked if there's a method or pathway to transition from online to on campus. So if you started online and then moved to campus in a couple of years after that, and then we can work down the questions after that.
Yeah. Yes. So there's definitely, we do have students that go between online and on campus. It's not a difficult transition at all. So, and certainly you can start online, get some coursework done, and then plan to come do your research on campus later. The primary thing to note is that funding opportunities are only available for on-campus students. And so online students don't have like the graduate assistantship positions. You can still apply for scholarships, but a lot of the funding opportunities we just discussed would not be available for an online student until you come to campus and are actually working on campus. I hope that answers the question.
Yes, it does. Thank you. Yeah, I've accepted a position up here in South Dakota still, but I'm very interested in getting a master's in systems engineering. So if I could transition at some point, that would be fantastic.
Yep.
Thank you.
So may I keep marching, Catherine? It looks like Caroline has a question about the funding opportunities moving forward. So the opportunities we've been talking about specifically right now are really for fall 2022. But I think the story there is that it's very, our job within the university is to go out and work with industry and work with the government to be able to get funding to support students to do this. So I'm speaking for the folks who are here. I think many of these opportunities will continue to be present in, January 2023 and in the summer after that and on and on. I mean, our goal is to keep keep training students and keep doing the research that we need to do. So what I would urge is, like if you, for example, are not quite ready to apply in fall 2022, but that's okay. Why don't you get in contact and just start making plans? And if there's the opportunity to apply and to make a reconnection with faculty about graduate research assistantships that would be relevant in 2023, I'm very, very happy to have that conversation. Would be delighted to keep that rolling. So maybe it's just recognized that these are not one-time opportunities, not one-time offers. We'd love to be able to engage with you at whatever time frame sort of works for y'all. So just do let me know if there's follow-up or that doesn't answer the questions or anything else like that. Adriana asks about the career placement after graduation. So at CSU, we do have a career placement office that's within the College of Engineering, a whole suite of resources that are available for students and all this kind of stuff. But what I would say is one of the most really potent ways to think about career placement in graduate school, especially, is it's a little bit different than undergraduate. And your faculty advisor and the people who are your teachers and all these kind of things, these could be really rich resources for you to be able to think about career placement. We very regularly have interfaces with industry where the rate of hiring of systems engineers right now is very, very high. I have students who come out of my master's program who have to get out early because they're being so sought after for positions right now. So I think that, some of that is stuff that we can do within the department. And then some of that I think is, a new and rich opportunity in coming to grad school is that you can really make some organic connections. The other thing I'd bring up is we do have a job board that is on the website, and you can kind of peruse and see what some of the opportunities for systems engineers might be and see whether those might be of interest to you. Syed asks about systems versus industrial engineering, and this is a very classic question. So when you think about, the way that industrial engineers sort of, think about industrial engineering is that it's a process of trying to, for example, optimize processes within a warehouse or in logistics systems or these kind of things like that. But industrial engineering really relies a lot on what are sort of, you might describe as kind of closed form solutions and very well-defined problems that we can apply rigorous optimization to. Systems engineering sort of takes a little bit of a different approach. It sort of asks, we're not only seeking, very well-defined problems in systems engineering. We're seeking to be able to think about problems that might not be well-defined. They might be very difficult problems. They might be socio-technical problems. They might be too big of scale or too much complexity to be able to reduce them to just an optimizable set. And so whereas industrial engineering really tries to make progress by applying mathematics and statistics and optimization and logistics to those very well-defined problems, systems engineering tries to make progress by really pushing, again, in a broader sense, thinking about how do we reduce complexity through modeling or through management or these types of things. So it's a little bit of a different perspective between the way that systems engineers and industrial engineers think about their field. Professional experience, Adriana brings up stuff about professional experience. So we have no such requirements or qualifications that we evaluate for students. Many times we do get folks who come out of industry and come back for a degree in systems engineering, but there is not, there's no preference that we express one way or another. Many of our students come directly out of undergrad, and many students do come from industry. Syed asks a question about the plan A. Do you want to try to address that, Ingrid?
Sure. Yes. So he asks, and we apply and choose plan A after you have maybe entered the program and are a little bit more familiar with the options for research. That is definitely an option. A lot of students do. They might not have any idea what they would want to do thesis research on. You can apply as a plan B student, and then I would encourage you in your very first semester to definitely do research and reach out earlier than later, because you don't want to be deciding 2 or 3 semesters in that okay, now I would like to do a thesis. So you can be admitted as a plan B and then change to plan A, but the strategy I would recommend would be to begin that process as soon as you enter the program and start taking classes.
Yep, I think that's pretty fair. The connection, it's obvious the connection to the faculty advisor is really important. And so that's what we're really trying to incentivize when we think about students entering in the thesis projects. Mohammed asked a little bit about GTA opportunities. So maybe the simple answer to your question is it would be pretty rare for a student to have a GTA opportunity in, like, for example, mathematics when their formal home is in systems engineering. But what I would really say, sometimes that question kind of comes from, oh, you might think, oh, I know a lot about mathematics because you took an undergrad in mathematics, but you don't know much about systems engineering yet. And that's okay, right? So don't sweat that too much. Oftentimes, the way that we recruit people to our TA positions, the GTA positions, is you come in and you take our fundamentals class, or you get very excited about, working with Dr. Herber, teaches a really nice class on optimization or something like that. And then the next semester, Dr. Herber needs a TA for his optimization class. Well, you've got a great background. You can do the mathematics with no problem, and you now have taken this class that you can help the next generation of students get through, et cetera, right? So I think the part of the point there is, don't think only about the expertise that you sort of have right now. Think also about what the GTA opportunities are going to be for you moving through the program. And if you sort of can keep it in that orientation, then I think we can be flexible. And our objective, of course, is to support you as you move through the program. So I know we're going to run out of time, right, Catherine? So,
Yep.
well, what I will propose then is this has been really nice to get to know you all a little bit. I hope this has been instructive to get to know our department and what some of the opportunities are here. I get, maybe next steps for this are if there are opportunities that you're excited about, if you have any questions or want to talk about these things, you should absolutely feel free to reach out to the faculty who've engaged here, to the staff who are working here on your behalf, and ask those questions and make sure that you're getting clarification and start making plans again to apply to and engage with our Department of Systems Engineering. From my point of view, again, I'm delighted to be able to talk here, be able to talk about what I think is an exciting project, and would really welcome you all to CSU if we get the chance to recruit you here. So thanks, Catherine, for efforts and for organizing this. Thanks to the students and audience, and look forward to more conversation.
Yes. Thank you.
All right. Cheers all.